So hello all, this is my new project. This project is called as a Basified. So Basified is actually the income package I have created for the basic achieve. So this package gives us some real-time insights about the transactions and contract deployments and their summary. So let's start with that. So in this npm package, I have added some methods by which I can extract the uh, how much contracts are deployed by the address, as well as how much transactions are done by the address, and we can provide more insights about that. So let's see how it does. So this is the npm package. And the name of the npm package is Basified. So I have not created the. You can download it from npm Basified, and I have not created the front end part of that, but I will show you the how it works in the backend. So it contains various methods such as getting the number of contracts by the address, as well as getting the deployment transactions and all. So I will hard code the address. So here is my MetaMask. So I have hard coded this address of MetaMask into my parameter. So like that, and we will see how it works. So the first function or the first implementation is the contract functions. So for that, what we have to do first of all, we have to take this address of MetaMask and we have to go on basically a block explorer. So just a minute. So it is redirecting me to the basically. So here you can see there are the three transactions made by this address on basically a chain, and one transaction is contract creation. So this this method focus on only that part that we have to fetch only the contract deployment transactions, and we have to provide inside of that. So let me just show you how it does. So our MetaMask address was same as I have shown to you in a basic full explorer, and when I will run this script, so it will give me how many numbers of contracts are being deployed by this chain or by this contract address, this contract address or this address is there. So here you can see the number of contracts are deployed are said to be the one, and this is the contract deployment transaction that has been done by this address. So you can see the same here in the basic folio attachment. The contract deployment transaction for the address is one, and all the insights are provided also out here. Now, this method filters out only the contract deployment transactions and how many contracts are deployed for the basic Julia network. So this was the first method. So second method was the so how many transactions. The second method is how many transactions are performed by this particular wallet address on the basic Julian chain. So first of all, we will get all the transactions, and after that we will get the internal transactions, and after that we will get the uh, details about the transactions. Now let's run this function and let's see how it does. So here you can see the number of the actual transactions are three, and you can see these three transactions out here in the basic Folia Explorer. Also, you can verify there are the three transactions by this address. Okay, and number of this is internal transactions. Sorry, so number of internal transactions for this given address is zero, and these are the transactions that has occurred. Like there were three transactions, so this is gonna be the first transaction that is there. After that, a second transaction, and third was the contract deployment transaction that I showed you. Suppose I have changed the address. Now let me change the address. I do not have front end, so I have to hard code it every time. So let me change the address out here and let's see what occurs. Now after that, and I have to do the same thing on the block explorer so we can cross verify the things. So yeah, so here you can see this wallet address has only particular one transaction out here. So let me just run my script and see if it is implementing the same. Yeah, so you can see here I have changed the contract wallet address to the different one, and it is fetching the different things for the different contract wallet address. And same thing, suppose I will know the contract function. So you can see is any contract is deployed by this wallet address, or is there, here you can see this wallet address haven't deployed any contract. So you can see uh, the number of deployed contracts are zero and contract based transactions are zero. So how these two functions work, this is how these two functions work with the block explorer. Now as we get the transactions, and let me change this address to this one because it has one contract deployed and we can see the things more clearly. So let me change this address out here in the script. So I have taken this transaction hash, and you can see the next function is getting the particular transaction. So this function generally gives the transaction script of particular transaction. Now let me run the previous function also, so you can get the insight. So yeah, now see. So these are the, so here you can see the particular transaction is out there, and I have hard coded that hash of the transaction, so it has given. So let me just take another hash. Suppose I will take this hash. Let me take a contract deployment hash. Yeah. So here it is. So let me just copy this hash, and let me just pass this hash to this one, this function, and let me just run this code. So it must get the contract deployment transaction for the same. Yeah, so you can see here the transaction is out there, and you can see the contract address which is out there, and all the things of the particular transaction from the transaction. So this is how the another function works. After that, the next function is to get the average gas fees used by the wallet address, and it is much straightforward. You can see the average gas fees is like the three transactions were done by this wallet address. So the average gas fees which is being used is something like that. And after that, the last function which is out there in this library is getting the latest block mined on this base affiliation. This particular package is made for only the base affiliation, but we can change it to the broader level and make it more interoperable and make it multi-chain and multi-purpose protocol, so that it can fetch all the other chains on the same package. So let me just run the last function and let's just see what happens. So here you can see the latest block is 1685851, and we can go on the block explorer and we can check for the same block. Uh, 8585 was there, so it has not 8551. So let me just run again. So it will 8562, now 8562, and here you can see the block is minus 7 seconds. So like that, it provides a sync with the block explorer also. So this was the whole idea of the project. Like it will provide the better insights, like it fetches out how many transactions are being done on the daily basis, how many contract deployment transactions are there, and uh, how much gas is being used, and what is the optimum way. So this is the whole idea of the project. Thank you.